Now, in this video, we'll have the corollary to this theorem 5.3.3. We'll just recollect what is this theorem. If v is the root of an irreducible polynomial p of x in fx and w is the root of p dashed of t in f dashed of t, f dashed t, then f of v is isomorphic to this f dash w. That is, we have this, we said already that the prime doesn't have any connection with our derivative. It is, we can even call it as f prime. So under this isomorphism, v is taken to w and alpha taken to alpha prime. So for that we had these mappings that whenever we have v to be a subcollection of fx, okay, and if we have that to be an ideal, every ideal is a principal ideal, so it can be generated by polynomial. So in this case, we consider that to be generated by this irreducible polynomial, and we had v to be maximal, and therefore this is a field, and we consider as a root of this p of x. So we can talk about the base field f and then the field adjunction f of v. This is also a field. This is a field. This is a field, and we had because v is algebraic, meaning it satisfies some irreducible polynomial. We are not bothered about the degree as such, so we can have this one to be true. That is, fx mod v is isomorphic to f of v. That mapping we take it as psi star, and then this is known to us already. That is, in the same way we have for v prime also. If p of x is irreducible, p prime of t is also irreducible in f prime of t. So the ideal generated by that polynomial, if we take as v prime, then we have f prime of t mod v prime isomorphic to this. So we took that isomorphism as theta star, and this is known to us by one of the earlier theorems. So putting all these together, that is, what we had was psi star from fx mod v to f of v. Now psi star inverse will be, because it's bijective, inverse will exist, and when you have psi star to be a homomorphism, you will have psi star inverse also to be a homomorphism. So psi star inverse from f of v to fx mod v is also bijective, and that is our psi star inverse. And from fx mod v to this, we took it as tau double star, and this is theta star. From this to this, theta star, f prime of w. Now combining all this, the composition gives us a mapping between f of v and f dash of w, and that mapping we took as some sigma. So sigma from f of v to f prime of w to be one-to-one, on-to, and homomorphism, and in turn it takes v actually goes to x plus v, and x plus v goes to, from here you have here, so from that it goes to t plus v, and from that it goes to w. So via all this only, this v reaches our w, and alpha is in, by all these, the base field elements are taken as such. So you have alpha taken to alpha first, and then to alpha prime, and then again to alpha prime. So alpha taken to alpha prime. So these are the things that we had in the previous theorem. Corollary to that is just it is the same as the previous one. The only thing is we have f of v and f dash of w, v as root of this polynomial and w as the root of this polynomial. But in this case, we are going to have the polynomial to be the same, but it has got two roots, say a and b. So that is the difference, only difference. Otherwise, the technique is the same. If a and b are roots of an irreducible polynomial p of x in fx, then f of a is isomorphic to f of b. Under this isomorphism, a is taken to b, A is taken to as before. A is taken to B, and alpha is taken to itself. Alpha is taken to itself for every alpha in F. So we will consider this. Let A be a root of this polynomial, irreducible polynomial. Then P of A is 0. B to be a root of this, so P of B is 0. You take V to be the ideal generated by P of X, then this is maximal. So Fx mod B will be a field. Now if you define psi as evaluation homomorphism from Fx to F of A in this way, then this psi is a ring homomorphism and kernel psi. All this what we said earlier, that is repeated again. So kernel psi is all those elements in the domain which are mapped onto straight. I should put it as so. Fx psi is 0, and that is nothing but f of a equal to 0. All those polynomials which vanish at a. Again, the same discussion that if you take it as m, then you have the relation to b. You have m contained in b contained in fx, and because this is like this, b contained in m contained in fx, because when you consider p of x at b it vanishes, at a it vanishes, so those functions which vanish at a should belong to m. That is how m is described. So v contained in m contained in fx, v is maximal, so one belongs to this, one does not belong to this, there is no other go, v equals m. So again the same explanation. So kernel psi is just v. Now by the fundamental theorem on homomorphism, fx mod v must be isomorphic to fx psi, but fx psi is f of a. Same explanation. So you take psi star to be fx mod v to f of a, that mapping which is one-to-one onto an homomorphism, which takes f of x plus v to f of a. So in that same mapping, x plus v will be taken to a, and alpha psi star will be equal to alpha itself. Now similarly for A you have got all this. Similarly for B you have all this. And remember, there is no F prime, so there is no V prime. All those things are not here. So you have this defined in this, again in the same way, and you have this to be true. Now since psi star is one-to-one onto homomorphism, also psi star inverse from f of a to fx mod b is also one-to-one onto an homomorphism. So what we are going to do now? We are going to have sigma to be. See, in the previous case, see it goes like this now. You have psi star inverse to be from f of a to fx mod v. And you have, here we have said fx mod v to f of b, it is theta star. F of b, it is theta star. From here to here only psi star. So from here to here means it is psi star inverse. So you have any element, I mean when you consider the composition to be say sigma, then it will be a mapping from f of a, this is wrong, f of a to f of b. Both of them are one-to-one onto, so the sigma is also one-to-one onto and homomorphism also, and therefore f of a is isomorphic to f of b. And when you consider a sigma, it should be taken to b. So a sigma will be a psi star inverse composition theta star. So that is nothing but a is taken to, this a is taken to x plus b, and that is in turn taken to b. So you have, this is small b, this is capital V, this is small b. So you have your a being taken to small b, and alpha sigma again as this. Psi star inverse leaves that one as such, theta star also leaves that as such. So you have this to be equal to alpha. So sigma takes alpha to itself. So we have just the replica of this theorem, we have this corollary. And because there is no f prime, see why we needed our tau double star, because of this only we needed this mapping, right? So otherwise straight away we are going from, because that prime thing is not here, so we are straight away going from f of a to f of b. No third mapping is not required. Only from these two you have and those two. So together only composition of two mappings. So that is the end of that proof. Next, we are going to prove the main aim of this section, namely uniqueness of the splitting field. So splitting field is what it is. Crudely speaking, it is the smallest field which contains all the roots of the polynomial. So the definition what's given in the book is this: if f of x is a member of fx, and if you consider E to be an finite extension of F, then you call E to be a splitting field over, splitting field of f of x, which is a polynomial over F, if over E, but not over any proper subfield of E, f of x can be factored as a product of linear factors. Very simply, if you want to define the splitting field is the smallest field which contains all the roots of the splitting field of a polynomial. Splitting field of a polynomial which contains all the roots of that polynomial. So if you now look at the definition given over here, it is the same. Over E but not over any proper subfield, which means this is the smallest field which contains the roots. So can be factored as a product of linear factors, means you have the roots lying in that. So it is the smallest field which contains all the roots of that particular polynomial, whichever you are speaking as splitting field of a polynomial, then this is the case. So the uniqueness we will have in the next video. Thank you.